A new manned device begins its ascent from rest with an acceleration that can be described by the following equation. After 3 seconds, a crew member releases a sandbag. Determine the maximum height the sandbag reaches and the velocity at which it impacts the ground. Since we are interested in tracking the trajectory of the sandbag, it is convenient to divide the problem into 3 stages. During the first time interval, the sandbag ascends inside the helicopter with the same velocity and acceleration. This happens during the first 3 seconds. After the first 3 seconds, a second stage begins in which the sandbag is released. The sandbag starts this new stage with the same velocity the device had at the moment of separation. From this point on, its motion is independent of the device's movement. Since its initial velocity is upward, the sandbag will continue moving in that direction for a while, although due to the effect of gravity, its speed will gradually slow down until it becomes 0, reaching its maximum height. From this point, the body begins its descent, influenced only by gravitational acceleration, and this would be the third stage. Now we have identified the 3 stages of the motion. Let's solve them one by one. The first stage is the blue dashed line, corresponding to the first 3 seconds. Our only input is the equation that defines the particle's acceleration. But this is not a problem, since with this equation, we can derive an equation for velocity as a function of time, and in turn for position, which in this case corresponds to the height. Let's start with the first equation, which gives us the velocity as a function of time, derived from the acceleration. The equation for the acceleration is already known. We just need to substitute the constants with their corresponding numerical values, resulting in the following form. From here, it is possible to obtain an expression for the velocity by integrating the acceleration with respect to time. The expression for velocity is important because it will allow us to determine the velocity at which the package leaves the ascending device. Let's proceed to solve this integral using the method of integration by parts or partial integration. If you need additional information about this method, you can download the document for free from the description. Let's obtain the parameters to carry out the substitution and solve using integration by parts. Remembering the equation for substitution and substituting the respective values. We have obtained an expression for the velocity at which both the device and the sandbag are ascending. By evaluating it at time t equals 3.00, we would find the velocity at which the sandbag leaves the ascending device. This velocity will also be the initial velocity for the next stage. It is also very useful to find the height at which the separation occurs, as this can be very helpful for calculating the impact velocity when the object falls to the ground. From this moment, the object moves solely under the influence of gravity, and we are now in stage 2. The object will continue ascending until it reaches its maximum height. We know that when this happens, its velocity will be 0, so we can find the time it takes for the velocity to become 0. Then, by substituting this time into the position equation, we will determine the maximum height. For convenience, we will set both time and position to 0 at the moment this second phase of the motion begins. Therefore, to this value of the height found, it is necessary to add the position from the first 3 seconds, which was previously determined. And with this, we have now solved the first part of the problem. Now we will solve the second phase of the problem. First, we need to understand that the third phase of the problem has begun, in which the object is in free fall solely due to the force of gravity. In this section, we are asked to find the velocity with which the object impacts the ground. Since the data we have is the height of the fall, the easiest way to solve this would be by using the equation for velocity as a function of distance. Since the initial velocity in this section is the same as the final velocity of the previous section, this velocity is 0. As for the final position, it is also 0 because it is at ground level. The initial position is the same as the one found in the previous section. Now we are ready to substitute these values into the velocity equation, where we find a value of 10.97 square feet per square second. This is not yet the velocity. To obtain it, we need to take the square root on both sides of the equation, resulting in a value of 3.31 feet per second, and this velocity is directed downward. With this, we have finished solving the problem. For more self-study resources, stay tuned for our updates.